Like 9, 10, 20, 21,
Okay, is there anything before 5?
I have 5.
Let's look at 5. Bryce, do you think clear back there, or do you need to wheel forward? All right. Number 5. Find 3 consecutive odd integers. How do we represent those consecutive odd integers? Okay. X plus 2, because they are odd, and there's a difference of 2 between each one. What's the next one? X plus 4. Now, if it just said consecutive integers, we would say x plus 1, x plus 2. Consecutive, even or odd, you got to say x plus 2, x plus 4. Now, some of you have in your mind when it says odd that you got to add odd numbers. It's if you were to represent them, you would have x plus 1 as your very first one. But when you saw, and then you could say x plus 3, and then x plus 5. I don't explain it to you or show you that to begin with, because if x were 3, 3 plus 1 would be 4. That's not consecutive odd integers. Here's the deal, is if you let that very first one be x plus 1, when you solve, x is going to be something like 4. So when you put it back in here, your first number is 5, 7, 9. And that seems confusing. I just like whatever x is to be the odd or the even that I need. So I do not do it this way. So even or odds represent with a difference of 2. 5. 6 times the sum of the first and the third. How do I show that? 6 parentheses times the sum of the first and the third. So 6 times the sum of the first and the third is 28 greater than, is means equal to, 28 greater than, greater, you're going to add, so go off to the side and add your 28. 28 greater than 8 times the second. And your second is x plus 2. From there, then you just need to calculate. So this becomes 2x plus 4. Use the distributive property and you're going to get 12x plus 24. Is everybody okay with me doing that? Or do you do? Yes. Okay. Or you could say 6x plus 24. I don't care. The next one, you're going to get 8x plus 16. Don't forget to use that distributive property. So 12x plus 24 is equal to 8x. And if you add those two together, you end up with 44. So I'm going to subtract 8x. And I'm going to subtract 24. So you get 4x is equal to 20, x is equal to 5. And what did they ask for? Consecutive odd integers, and 5 is odd, right? So that's our very first integer. If you would have set it up as differently than x plus 2, x plus 4, you run the risk of that being an even one, sticking it back in. But don't stop with just x equals 5. Your consecutive odd integers are 5, 7, and 9. Another question. 13. So number 13, you have negative 3 times the quantity x minus 2 plus 1 minus the quantity negative 2 squared minus 3 times the quantity x minus 2 equals 5x to the 0 times the quantity 2 minus x, and then minus 2x. Orders of operations, where do you want to focus first? Parentheses. So I want to simplify inside the parentheses by grouping the like terms together. And that's the only thing I can do. So within that same step, is it okay if I take care of these exponents? All right, so my first step, you're going to have -3. In the parentheses, you get x minus 1. Minus, this negative sign gets brought down, and you have -2 as your base. What's -2 times -2? 4. So it shows up as -4 right there. -3 times the quantity x minus 2 equals x to the 0 is the same thing as the number 1. And 5 times 1 is 5. Question up to that step.
No.
What's next thing? Distributive property. So if you distribute, you get -3x plus 3 minus 4. Now you're going to distribute -3 again to give you -3x plus 6 equals, distribute the 5 to give you 10 minus 5x minus 2x. Now what? Yep, we're going to group like terms on both sides of the equation, simplify both sides. So we end up with -6x plus 5 equals 10 minus 7x, or -7x plus 10. Now you want to move the x to one side, the constant to the other. I don't care which way you move it. If I move the 7x over, it becomes positive 7x. And if I move the 5 over, it becomes -5. So you get x is equal to 5. Concur? There's just lots of values. You just got to keep it straight, keep it neat, keep it clean as you go through.
$29.
29 has -3 to the -2 power. Minus 2 over the opposite of 2 to the -3rd power. Minus 2 to the 0. Okay, I just want to three, I'm going to let B a T for trio. 2, I'm going to let B a D for dose. Duo, 2. Okay. What if I give you the problem that looks like this? Oops, 2 is a D. Sorry. All right, if I give you the problem with variables, would you know how to solve that? What, Jared? Move this up, making it what? D to the 3rd, which makes this term right here become what? D to the 4th. What happens right here? Turns into a positive. What's anything to the 0 power? 1. And how can I make that a positive exponent? Is this term going to be positive or negative? Negative. That negative is not it doesn't look like this. That would make it positive. It is not that. It's just the opposite. So I could show this as 1 over t to the 2nd. Would you agree with that? What did we say t was? 3. So this is like -1 over 3 squared plus what's d? 2. 2 to the 4th minus 1. What's the opposite of 1 over 3 squared? -1/9. What is 2 to the 4th? Minus 1. 16 minus 1 is 15. 15 minus 1/9 is 14 and 8/9.
Okay.
Now, if you're looking at it with numbers, as you look at that with numbers and you're trying to solve that problem, let me regroup this here and clone it. So let's say you didn't want to put variables there and you're looking at the numbers. Here's kind of a systematic approach that I do. I look at the first term and I say, is that first term going to be positive or negative? It's going to be negative because the -3 is not the base. The only thing being raised to that power is +3. Right, so your -3, or your answer is going to be negative. You have 3. I take the base, which is 3, raised to the power, what's 3 squared? 9. And that negative exponent says, move it to the reciprocal. We look at the next term. And if I look at the next term, I'm going to ask myself the same thing again. Is that going to be a positive or a negative term? Both of those negatives happen to stand alone, so those two negatives turn into a positive. Then I can ask myself, my base is 2 raised to the 3rd power is what? 2 to the 3rd is 8. Flip it. So I put my 8 in the numerator, but what you do to those two numbers is you multiply them together. Don't add them. That's a common mistake you see as you add. But just like when I put the variables in there, if I move that up, you were multiplying those bases, you add the exponent. Here you multiply the bases, multiply your values. So you end up with 16. And then of course that last term right there, it's going to be a -1 because it's not, the negative is not in parentheses with the 0 outside of it. And then you're back to the same value that we had right here. And then when you group those together, you end up with 14 and 8/9. But my approach is always figure out what is your base. Is it 3 or is it -3? Is it 2 or is it -2? Raise it to that power and see if you got to flip it. Another question. Bryce, did you have one? Jonah.
Oh, good. 25.
Okay, there is 2 different approaches you can use for 24. You have a to the -2nd b, and then we have minus a times the quantity a minus b. The 2 different approaches that you can use, let's see, a is equal to -1/2. What's b equal to? 1/4. All right, I don't know if the problem is just because we have fractions. But if you remember back when we were learning these last year, what I said is you got to change your letters or your variables into parentheses. Parentheses change into brackets. A minus B. There we go. So I could set up the problem, let A be -1/2 and B be 1/4. And now I have to solve that problem. So once again, what is your base here? Your base is -1/2. And I am raising it to the 2nd power. So what's -1/2 times -1/2? 1/4. And then that negative exponent says, flip it. So instead of 1/4, you get 4. times 1/4 minus negative 1/2. If I look at these two negatives right there, that changes into plus 1/2. Is that okay with everybody if I do that? What's negative 1/2 minus 1/4? Negative 3/4. This is the same thing as it's the same thing as 2/4, so you get negative 3/4. Now, what's the number times its reciprocal? 1. If you multiply the second term together, you get negative 3/8. What's 1 minus 3/8? 5/8. Do we concur? Now, there's other things you can do to solve this problem besides what we just did by using your parentheses and your brackets. Sometimes it makes it easier, sometimes it does not. I will tell you on one test, I don't remember if it's in Algebra 2, Algebra 1, that if you do this next procedure, it cancels out some terms and it makes it really nice. But what you can do is you can take that expression that we have right here, and another method that we could use is to go ahead and distribute right here. So then you get a to the negative second b, and if I use the distributive property, you get negative a squared, and then you get plus ab. Maybe some of you would rather do that, so you're not using the distributive property or anything with a fraction. I don't know. That's up to you. You could write it as positive exponents if you wanted to. B over a squared minus a squared plus ab. You could write it that way before you started to do your substitution. That's okay as well. I don't care how, if you like dealing with negative exponents. If you don't, I don't know. If you do that, b had a value of 1/4, and you were dividing that by negative 1/2 squared minus negative 1/2 squared plus negative 1/2 times 1/4. So you end up with 1/4. What's negative 1/2 squared? 1/4 minus negative 1/2 squared is 1/4, and if you multiply, you get negative 1/8. So now if you solve, what's 1/4 divided by 1/4? 1. So you have 1 minus 1/4 is the same thing as 2/8 minus 1/8, and you get 1 minus 3/8, which is 5/8. I don't care. I don't know what's easier for you. To distribute, so you just have individual terms, not all these brackets and parentheses and all of that stuff. I don't know. I just want you to know that that's another option, and sometimes it does tend to be a better property to use first, or a better method, algorithm to use first, because certain terms would cancel out. There's no like terms there, so you can't join anything together. But just keep that in mind, as that is an option. Bryce, you had one? Six. Find 4 consecutive integers. Now, how do we represent consecutive integers? There's our consecutive integers, and we have 4 of them, such that 4 times the sum of the first and the fourth. 4 times the sum of the first, which is x, and the fourth, which is x plus 3. So you have 1, 2, 3, 4. The sum of the first, 4 times the sum of the first and the fourth is, which means equal to, 24 greater than 6 times the third. The third is x plus 2. So now we solve. This is 2x plus 3. So we get 8x plus 12 equals 6x plus 12 plus 24. I am guessing you move the 6x over, move the 12 over. So you get 2x is equal to 24. What is x? 12. So your consecutive integers are 12, 13, 14, and 15. It is 12. 12 plus 1, 12 plus 2, 12 plus 3. Jared?
So
The surface area of a sphere is 46 pi square centimeters. What is the radius of the sphere? What's the formula for surface area of the sphere? 4 pi r squared. How do I solve an equation like that to solve for r? Divide by 4 pi. This is not going to be a nice looking answer here. Right, so 4 pi's cancel. So you get r squared is equal to the pi's cancel. 46 over 4 reduces down to 23 over 2. Okay, that's one way. I'm just going to give you, I'm not even going to reduce it here for a second. I'm going to give you a little insight into radicals. Because I just told you, how do you get rid of a square? You take the square root. So for you, at the level you're at, you could just go ahead and say the answer is the square root of 46 over 4. I would have accepted that as an answer, okay? It's not going to be a nice number. You don't get your calculator, so you can't change that to a decimal value. Now I'm going to tell you this much. If you reduce that, you could have told me your radius is equal to the square root of the fraction 23 halves. I would have accepted that as an answer as well, because you've reduced your fraction. What you're going to get into is when you take the square root of a fraction, say the square root of 46 over 4, what you do is you take the square root of the numerator over the square root of the denominator. What's the square root of 4? 2. So your answer could be the square root of 46 over 2 centimeters. So you take the square root of a fraction. Now something else about radicals is when you talk about radicals, I mean, what's the square root of 9? 3. If you were to think about it, what's the prime factorization of 9? 3 times 3. If you have a pair, because you're taking a square root, if you have a pair, you pull it outside the radical sign. So I pull the 3 out, and that's why the square root of 3 is just 3. If I talk about 46, what's the prime factorization of 46? 2 times 23, right? Do I have a pair? No. So I cannot simplify the square root of 46. So it just remains as the square root of 46 times 2. If you talk about the square root of 8, the square root of 8 means the square root prime factorization is 2 times 2 times 2. This index right here is understood to be a 2, so you have to have a pair. So you take this pair right here and you move it out. So the square root of 8 is the same thing as 2 radical 2. Those are equivalent to each other. And this is the way that they would want you to write it. That's the simplified radical form. You think about that square root of 8. When you multiply radicals together, you multiply what's known as the radicands. That's the numbers underneath the radical sign. So another explanation of that 2 radical 2, this square root of 4 times the square root of 2, 4 times 2 is 8. Those are equivalent to each other. But what's the square root of 2? or the square root of 4, sorry. I knew what I wanted to ask. The square root of 4 is 2. So you end up with 2 radical 2, and that's the simplified version of the square root of 8. This is something you cannot wait to do yet this year, because you will do it. You will do the radicals and stuff this year, yes. Actually, probably not too. Yes, you do. John. 25, you have m squared p times mp minus p squared. M is negative 1/4, and p is equal to 1/5. Okay, once again, there's 2 different ways you could work through the problem. You could either go ahead and set up your parentheses and your brackets and substitute right away. M squared times p, the parenthesis becomes a bracket, m times p minus p squared. Or you could use the distributive property. If you use the distributive property, what are you going to get when you distribute? M to the third, p to the second, minus m squared p to the third. So you could distribute first and then say you're going to have m cubed p squared minus m squared p cubed. Which one do you want to substitute into, the green or the blue? How many for the green? How many for the blue? I don't care. M, what's M? Negative 1/4. What's P? 1/5. When you take a fraction and you raise it to a power, you cube the numerator, cube the denominator. A negative cubed, is that going to be positive or negative? Negative. 1 cubed is 1. What's 4 cubed? 16 times 4, 64. What's 1/5 squared? 1/25. Minus negative squared is going to be a positive 1/16, and 1/125. Wow, look at that. And you want to talk about a common denominator. Now, as you think about a common denominator, you could look at factors. This is going to be 1/64 is 4 times 4 times 4. 25 is 5 times 5. Minus 1/16, which is 4 times 4. And 125 is 5 times 5 times 5. Guess what? To get a common denominator, you need another 5 here. And you need another 4 here. Now, do the denominators look the same as far as factors are concerned? Yeah, that was pretty easy to get a common denominator, right? So your answer, what is 5 minus 4? 1. Now I got to multiply, and what I'm multiplying is 4 times 4 times 4 times 5 times 5 times 5. What's this? 20 times 20 is 400 times 20 is 8,000. It's going to be 20 times 20 times 20, or 20 cubed, which is 8,000. Maybe my 4 and my 5 are not correct. Oh, right there. I missed that sign right there. There's the negative. That's a negative. And the what? I did that because it was positive 5, so I did 5 minus 4 was 1. Is it negative 9? Negative 9. I missed this sign right here, my bad. I missed that sign right there. So you have negative 5 and negative 4, which is negative 9, because I put those values in the numerator, 5 and 4. It looks bad, but if you think about how to get that common denominator by splitting it into factors, it's a lot easier than taking 64 times 25 and 125 times 16. Now, I'm not going to say this method's going to be any better. I don't know. Put your values in. M is negative 1/4. And P is 1/5. So you go through what's negative 1/4 squared. Positive 1/16 times 1/5. And in brackets, you're going to get negative 1/20 minus 1/25. 1/5 squared is 1/25. Back table. I hope that's a math problem we're discussing. Otherwise, you're going to be moved into individual seats in the classroom facing me. You multiply 16 times 5, 80. Inside the brackets, you get a common denominator. What's the common denominator? 100. So you multiply the first one times 5, the second one times 4, and you get negative 5 and negative 4, which is negative 9 over 100. If you multiply those two together, you get negative 9 over 8,000. Other questions? 10, and then I'll get to 14. I have 7 and 10 marked as 2 that are most frequently asked, and I have the word board next to them. If A is the measure of an angle, 180 minus A is the measurement of the supplement of an angle, which makes sense. If I tell you I have an angle that is 60 degrees, what's its supplement? 120. And you found that by taking 180 minus the angle that I tell you. If I tell you I have an 80-degree angle, what's its supplement? 100, because it's 180 minus 80, right? How do you think you would talk about a complement of an angle? If my angle is 30, what's its complement? 60. If my angle is X, what's the complement? So here are 2 things you might want to jot on a note card. If you don't know the angle, the supplement of your angle is going to be 180 minus X or A or whatever they want to call the angle. The complement of your angle is going to be 90 minus X. So number 10, it says if the measure of an angle, what do you want your angle to be? A or X? Or B or C or Y or what? X. If the measure of an angle is, means equal to, if the measure of an angle is twice the supplement, twice, and I'm going to put an S for supplement. What is the measure of an angle? When you think about supplement, how do we show supplement? Supplement is 180 minus X. So you have X equals distributive property. You get not a 2. Oh, I was just better off to erase it. Distributive property, you get 360 minus 2x. So I'm going to move the x over by adding 2x, and you get 3x is equal to 360. What is x equal to? 120. What would its supplement be?
Or, no,
60. And what did they tell you? They want you to find an angle that is twice its supplement. Is your angle twice its supplement? Yes. So your angle is 120 degrees. Is that all of them?
14.
What one?
14.
14 says -3 minus 2 squared. -3 minus 2 squared minus 2 times the quantity x minus 3 equals 2. Are we all right?
yeah, I was there.
All right, there's your problem. Where would you start? I would probably start with that right there. What's that going to have a value of? -3. So can I just put that -3 right there? Is that all right? Now here's the problem. Some of you are going to write it this way. You're going to go x minus 5, and then you're going to say, oh, that simplifies into a -3. And now what does that mean? It means -3. But what operation are you doing between these two? Multiplication. You need to put your -3 right there. So you're going to have -3. Is this term positive or -4? -4. I'm going to use the distributive property to give you -2x plus 6. Now you can multiply, well, okay, we'll do it this way. 2, and inside the brackets you get -3x plus 15. If you wanted to, you could take the 2 times -3 and then take -6 through. But we'll just leave it this way. Group like terms together, you get -2x minus 1 is equal to -6x plus 30. Are my calculations okay with everyone so far? You move the 6x over, making it positive 6x. Move the 1 over, making it positive 1. So 4x is equal to 31. What is x equal to? 31/4. All right, I'll take those papers. You need to, tomorrow I'll work with the other group so you can work on your review in the back, which I have printed off. If you give me a second, I'll pass that out to you. You can ask any final questions. Your test probably will be Thursday.